Easy one, right? Up and down. But now, maybe it's over there, and I got, again, if it's the same now as this, isn't it? Okay, so it kind of like, it's like the opposite sign. Or, I don't know, I'm not going to tell you how to know this. Maybe you want to keep saying to yourself, I'm putting it over there, and I remember that from Math 11, so that's what I'm going to do. Okay, I can't tell you how to make sorts of this stuff. But if you want the mark, you're going to have to find a way. We just looked at yesterday what the sign of A does, right? And if A is positive, this is, again, what we knew from last year. That was a parabola. If A was negative, that got reflected over the x-axis. Because, again, that negative, maybe it's here, but I could put it here. And then we looked at, well, what happens if that's negative? That's a reflection over the y-axis if it's on the x, right? Now we're looking at the magnitude of A. What does A do as far as a number? Because there, all we did yesterday was that, right? Minus 1. Now it's going to be a number. And do we remember what that did? Here's our good old y equals x squared. I'm actually going to make a table, even though we've seen this about 6 times, because I'm going to compare it with other things. So x and y. Nice values of x. And then what does y become? 4, 1, 0, 1, 4. Okay? And then, yeah, we could put in some other things and figure it out too. Right? Now, here's what we saw in Math 11. We put a 2 there for A. What did that do? If you remember, great. But let's make another table of values and figures it out. Again, what's happening around the origin? It's probably the area I'm concerned about. So if I put in negative 2 here, I get 4 times 2 is now 8. Used to be 4, now it's 8. I put in negative 1, that's 1 times 2, that's 2. Used to be 1, now it's 2. 0, still 0. 1 is going to be 2. 2 is going to be 8, because again, this thing's symmetrical, isn't it? So, not 1, 1, 1, 2. Not 2, 4, but 2, 8. And that's pretty much all I can graph, right? This thing's symmetrical. Again, that thing's got arrowheads. Don't just tell me it stops there. It goes forever and ever, the first one. So what did the 2 do? Reese? Yeah. Okay, skinnier was a word that worked last year. I don't think that word is anywhere in this book. This was a vertical stretch. Even that word's not in this book. It's an expansion. Good. This is a vertical. Well, kind of says it here, doesn't it? Yeah. Oh, yeah. Expansion. That's our only 2 choices. So it's actually easier in that respect compared to the book we had last year that said like 4 different ways to say the same thing, like in typical English fashion. Or, in short, VE. Vertical expansion. Now, does that word kind of make sense? What did I say last year? I said last year, think of this as like a rubber band. If I pull on these 2 ends, what will happen? It will get skinnier. I will expand it vertically. That's a vertical expansion. Okay? That's the only way I can say it to you, to hopefully make it make sense. All right? What factor is this expanded? We need to know that too. Green. Yes. Let's look at this point here. 2 was 4. Now 2 is what? This 2, here's another way to say it. All the y values are twice what they used to be. Not like the old days, right, Lewis? Hey, here's twice what they used to be. Okay, not twice as good, just twice. That's a vertical expansion by a factor of 2. Okay? That's also important because we're going to get lots of different numbers, not just 2. Going to get a 3, going to get a 4, going to get a 5. Okay? So this is now twice as big as it used to be. And something else. I can write that also like this, can't I? Can I divide both sides by 2 and write it like that? We didn't do that last year. Maybe that's how you want to look at it. In a lot of cases, that's true. This says the same thing as this, right? So I'm not used to seeing it like that, right? This is the only second time I've done this course, and I've forgotten what I did before. So a way for my brain to make sense of this is, if there's a number multiplied by y, and it's less than 1 and greater than -1, I can't just say fraction, because it might be an improper fraction. This is less than 1 and greater than 1, I get a vertical expansion. Okay? This is a factor of what? It's a factor of 2. When that's a half, flip the numbers. 2 over 1. So if I said to you, how could I get a vertical expansion of 3? What would I have to do to y equals x squared? What would I have to do to y? Yeah. Okay? Or 1/3 times y, which would be the same thing as putting the 3 over here. What does that do? Is that a value less than 1 and greater than -1? So that's going to also be a vertical expansion. What's the factor? Okay, what was the factor here? 2. What was the factor here? 3. What's the factor here? 1.5, or 3 over 2. Okay, same thing, just flip the 2 numbers. All right? So that's a number less than 1, greater than 1. What if I have a number here greater than 1? Let's go back to grade 11. If this thing made it skinnier, what do you think this is going to do? If all the y values are half what they used to be, let's make a table. If x is -2, I got 4. What's half of 4? 2. If I got 1, what's a half of 1? Half. I got a 0. What's half of 0? Still 0. A half. 2. So I got that point. I've got x is 1, y is a half. If I got x2, y is 2. And this thing's symmetrical. And you might use the word fatter last year, that would be fine, but now we got to call it a vertical compression, or a VC for short. What's the factor? 2 used to give me 4, now 2 gives me half of that. So it's a vertical compression by a factor of 1/2. Okay, all the y values are half what they used to be. Okay? So we're still kind of, that's a little bit fresh in our brain still? Take that as a yes. Any questions? Now guess what we're going to do in Math 12? We're going to do it with x2. Here's our good old unfamiliar y equals root x. Only works for positive values of x. So, should I graph this? I don't know. Maybe I should just look up here. For x, what did this do when I put a 2 beside the y? When I put a 2 by the y, what did it do as far as y is concerned? It was a vertical compression. This is going to do the same thing with x. If I put a 2 there, that is going to be a horizontal compression. What's the factor? Take a 2 over 1 and flip them around. That's a horizontal compression by a factor of a half. So all these values will be half what they used to be. Okay? So this one's 1, 2, 3, 4. It's going to be 1, 2. I'm a little more curved. Okay? Should I quickly do a table of values here to kind of prove it? Wouldn't be a bad idea. But what kind of values do I want to use? Well, if x is 0, y is still going to be 0, right? What's a nice value of x here? 2, because I know the square root of 2 times 2. I know the square root of 4 is 2. 2 is 2. There it is. I'd like to do the square root of 9. What value of x is going to make this 9? 4.5. And y will be 3. 1, 2, 3, 4.5. 1, 2. That point should be right there. Okay? So, horizontal compression. If I squish this thing and compress it vertically, it makes it fatter. Same thing in the x direction. Not vertically, but if I compress it that way from the right, it's going to make it fatter. Okay? You see that? So it's the same thing, only just move your head, turn it 90 degrees. Okay? Let's look at this guy. Can you see that? Not really. Where's another lace? I don't want to use yellow. I always use yellow. Orange. Can you see that? Do we see orange? Almost looks like brown up there. It's definitely orange on my tablet. Okay? When I put a half with the y, what happened? A vertical expansion by a factor of 2. If I put a half with the x, guess what's going to happen? A horizontal expansion by a factor of 2. So if I pull on the end of this guy and stretch it, it's going to be skinnier. Okay? It's going to, looks like hex. Horizontal expansion by a factor of 2. So that point's going to be there. This point is going to be here. And it should look a little skinnier. It's only half of the curve though, so it's a little bit tougher. Quickly, maybe I should prove that. What are some nice values of x here? Well, 0 and 0 is still 0 and 0. What do I want to use here to make this thing a 1? What's going to make square root of 1 here? What value of x? 1, 2, that should be there. Okay, should be a little higher. And if I put in 8 here for x, what's 8 over 2? 4. And we know the square root of 4. I did that the second time today this thing's cut out. Don't worry. Just a temporary glitch. Do you guys, anybody live around here know the power's going out Sunday for, is that this Sunday?
For what?
You haven't heard that?
For what?
Yeah, Chase area? On Sunday for, That's weird. Heck is that? I don't know. I'll just press that button. Just to let you know, thinking of power outages. So,
Is there a reason or just?
oh, sorry, the square root of 4 is 2. You don't want that there. 8 is 2. That was pretty close. That one's right there, okay? But it's definitely horizontally expanded. Now, should I say something really confusing? And say like a horizontal expansion is very similar to a vertical compression? No, I better not say that. Okay, I agree it's not. So, you got to make sense of this, okay? What do you do in biology when you're trying to really trying to get stuff into your head and figure it out?
Over it like 10 jillion times.
Flashcards? Not a bad idea. Okay? You got to know what this stuff does. I can't tell you how your brain works and how you want to try to stuff it in there.
Hit the book on your head to learn about osmosis.
Oh, that might work. Oh. Let's give it a try.
Biology, right?
Okay, quick little graph. Let's see what this stuff does. I want to point at the origin. That color okay? We can all see that?
Yeah.
Oh, let's put a point here on 6, 0, and then 1, 2, 3, negative 2. And make yourself a little semicircle. That's y equals f of x. That's the original graph. Now I transform this function by doing this to it and this. So what does the 2 do? Well, I could also write this like this, couldn't I? So if you want to go back to grade 11, fine. All the y values are going to be twice what they used to be. Or try to put it in terms of what I'm trying to show you today. If there's a fraction less than 1, this is a vertical expansion by a factor of 2. Okay, so vertical expansion, oh, I better not do red. That's what this does. So all the y points are twice what they used to be. What is 0 times 2? Doesn't change. What is negative 2 times 2? That point becomes that point. And then all I want to look at is this point over here. But this point for y is 0. So what's 0 times 2? That one doesn't change. So first I have this. That's what this 2 does. Okay? All the y points are twice what they used to be, but don't try to micro-analyze each one and double them. That's good enough, okay? Good enough. I'm not going to pull my ruler out and measure it. Sorry? Yeah. It's a happy graph. What does this 3 do? Okay, if it's a fraction, it's a vertical expansion. This one's on the x, so it's horizontal. When it's a number bigger than 1, that's a compression. If the fraction is an expansion, then the whole number is a compression. This is horizontal because it's on the x by a factor of, how much is this compressed? 3 over 1, flip them, by a factor of 1/3. So now I want to horizontally compress it. Horizontal means the x points. Here, I want 1/3 of that. What's this? 1, 2, 3, 4, 5, 6. And they usually will work out kind of nice, okay? What's 1/3 of 6? 2 by 1/3. It goes here. Okay? Goes in by 2. Right? 1/3 of 6 is 2. Yeah. It doesn't go to 2. I think I just said that kind of wrong. Okay, by a factor of 1/3. This is 3. I want to take 1/3 of that. So this point goes to here. This point goes to here. And what is 1/3 of 0? That one doesn't move. So my final graph looks like this. Okay? The purple thing, at least that's my color, is that. Okay? So vertically expanded, horizontally compressed. In general, you're late. This point is on the graph y equals g of x. What does this do to it? There's 3 things there. Let's start out with the one that was on your quiz. What does the negative do? I guess you're ready for your quiz. Reflection over where? X-axis, right? That's on the y, it's not on the x. It's not a negative here, it's a negative there, okay? So, if 2, 3 is reflected, again, you can, if you want, you can try to do that. That's reflected over the x-axis, that's going to be 2, negative 3. And then what does the 3 do? That's a fraction on the y. That's a vertical expansion by a factor of 3. So that becomes 2. Negative 3 times 3 is negative 9. Lastly, what does the half do? On the x, that's a horizontal expansion by a factor of 2. Let's write that out. Yeah, I didn't write that one out. So if I horizontally expand that by a factor of 2, that becomes 4 minus 9, and that's it. All 3 transformations. So is this confusing? Yeah, you're damn right. But I'm not the man who says this is what the kids need to know. I'm just the guy who delivers it. Don't shoot the messenger. In general, some relation becomes that relation. What happened when I put a 2 on the x? If it's a fraction less than 1, it's an expansion. If it's a number bigger than 1, it's a compression. This is on the x, so it's a horizontal compression by a factor of 1/2. It's half as big as it used to be. It's compressed. And on y, if it's a fraction less than 1, it is a expansion. On y, vertical by a factor of, it's not a half, it's 2. Okay? This is why we want to look at it like that. Okay, and not necessarily like this one. Because it's not always going to look like that. Okay, it's going to be like a nice fraction. Okay, so that's just going to do two things. That's it. I don't see any negatives or anything else. Check that out and then do the assignment.